Welcome. This is HL chemistry and SL chemistry. I wanted to take another quick look at the index of hydrogen deficiency. Okay, and again, the index of hydrogen deficiency, or IHD, is how many hydrogen molecules needed to saturate a compound. Okay, or how many hydrogen molecules we've removed from a compound in order to make it what it is. Okay, so I want to look at vitamin D. So we can look at a structure and calculate its IHD. We can look at a formula and calculate its IHD. Okay, if we're looking at a structure, say propanone. Okay, it's as simple as counting all the rings and triple bonds and double bonds that are there. So this one would have one double bond, so our IHD is 1. Okay, to calculate this just based off the formula for propanone is C3H6O. Working off the empirical formula I find is easier. But we can calculate IHD by simply calculating the total number of hydrogens this compound would have if it were a straight chain alkane. So we can use the formula CnH2n plus 2 to calculate how many hydrogen atoms there should be, okay, and then dividing by 2 to calculate IHD. All right, so n is 3 in this case, so 2 times 3 plus 2 is 8. All right, there are 6, though, in this compound. So subtract 6, you get 2 hydrogen atoms missing. Divide by 2, that's an IHD of 1 H2 molecule. Okay, we can also, if we have a nitrogen here, we're going to add 1. If we have a halogen, we're going to treat it like a hydrogen and subtract it. Okay, so this is formula gets used a lot, and we can mess with that. But what I want to look at today, most importantly, is how do we look at a formula and determine how many of these different structures we might have. Okay, so if I want to look at something like vitamin D, which has the formula C27H44O3. Okay, so I can calculate the IHD, and it'll give me a rough estimate of how many of these structural elements I have, how many double bonds, triple bonds, rings, or aromatics I might have in this compound. It's not going to tell me the exact structure, but it'll give me a list of options, essentially. Okay, so if I calculate the IHD, we're going to use 2n plus 2 again. N is 27. That means this should have 56 hydrogens. If this was a straight carbon chain of 27 carbons length, we would have 56 hydrogens here. We don't. We have 44. So we'll subtract that out, and we're missing 12. We're missing 12 hydrogen atoms. Okay, so that's divided by 2. That's an IHD of 6. All right, so we're missing 6 hydrogen molecules. All right, so what are our options here? Well, a double bond, to form a double bond, we lose 1 hydrogen molecule. So we might have 6 carbon-to-carbon double bonds, or carbon to oxygen double bonds. Okay, double bond is a double bond when it comes to this. Forming an alkane ring also removes a single hydrogen molecule, so I might have 6 rings. Those could be 5 carbon 4 carbon, 6 carbon, most likely they're 5 or 6 carbon rings at this point. But just forming that ring removes a single hydrogen molecule. Okay, an aromatic, to form an aromatic like benzene, an aromatic benzene ring has IHD of 4. So I might have one benzene ring. Sorry, I was recording. Sorry. I might have one benzene ring, one aromatic, and maybe 2 double bonds. Okay, that would add up to 6. Benzene ring is 4, 5, 6. Okay, I could also have triple bonds. A triple bond, to form a carbon-to-carbon triple bond, removes 2 hydrogen molecules. Okay, so it has an IHD of 2, so I might have 3 carbon-to-carbon triple bonds. Okay, so I can have any combination of these things as well. I might not have just 6 straight carbon-to-carbon double bonds. I might not have 6 straight rings, but I have a combination of these two, or a combination involving triple bonds, or a combination involving this aromatic. Okay, so if we look at the structure of vitamin D, what it has, so it has a 6 carbon ring, with a double bond there, and another 6 carbon ring with a 5 carbon ring attached, and we've got a double bond there and a double bond there. Okay, so what do I see in this? What exactly do I have? Did I nail it? Did I find some combination here? Well, we have 3 rings. 1, 2, 3. 2 of them are 6 carbon rings. 1 of them is a 5 carbon ring. Doesn't matter. Still an IHD of 1. Okay, and then I have 3 double bonds. 1, 2, 3. Okay, so 3 double bonds. These are all carbon-to-carbon double bonds, and 3 rings. This is IHD of 6. Okay, so we can use this to tell us what structural elements we have, or at least give us a list of the different structural elements we might have. Okay, I hope this helped. If you have any questions, hit me up on email, and I will be happy to answer them. Thank you, guys.